Hi future doctors, welcome to the next class. In this class, we will discuss about inelastic collision, perfectly inelastic. So what is meant by inelastic collision means after the collision, both the objects will move with combined velocity or common velocity. So two objects generally we will take m1, m2 with velocity u1, u2. Then after collision, so both m1 and m2 are moving with same velocities. That is nothing but common velocity. So in this collision, so we said already only momentum conserved, but no kinetic energy. Kinetic energy will not be conserved. Now, if momentum is conserved according to law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But velocities are same. Therefore, we will write m1 u1 plus m2 u2 is equal to m1 v plus m2 v. So, m1 u1 plus m2 u2 is equal to m1 plus m2 into v. So, v is equal to m1 u1 plus m2 u2 by m1 plus m2. So, this is nothing but common velocity of these two objects after the collision. How they are going to ask this collision concept in exam? A wooden block of mass m is suspended. So, a bullet is fired of mass m with initial velocity u. After hitting this bullet, so this block is going to be moving or rising with the bullet. Bullet is going to be embedded in the block. Then both bullet and block are going to move with common velocity. So what is that common velocity means? This formula we are going to apply. So according to this formula, common velocity V equal to, so mass of the bullet, velocity of the bullet. Now this is at rest position. Therefore, 0, u2 is 0 divided by m plus m. This is going to be mu by m plus m. This is the common velocity of this block and bullet system. So how much height it is going to be rising, they will ask. How much height it is going to be rising means here kinetic energy should be equal to here potential energy. That is only law of conservation of energy we are going to be applying. So here kinetic energy means of m plus m this v square equal to m plus m g h. If you equate, you are going to get. Otherwise, simply you can apply maximum height formula u square by 2g. Here what is u means that common velocity. So like this we are going to apply very easily. So this is during the collision. Which collision? Inelastic collision. So but elastic collision there is kinetic energy also conserved. Therefore there is no loss. But here kinetic energy is not conserved. Means initial kinetic energy is not equal to final kinetic energy. Therefore some loss of kinetic energy will be there. How we will get that loss means, so initial kinetic energy minus final kinetic energy or final minus initial, anything we can do. So what is initial kinetic energy means here? Of m1 u1 square plus of m2 u2 square. This is initial kinetic energy minus what is the final kinetic energy of m plus m or m1 plus m2. We use here m1 plus m2 for this collision. General formula I am writing. After that, for this case also we can write if you want. So m1 plus m2 of m v square. What is v means here? This common velocity. If you substitute these two, just I am writing formula. If you want means you can calculate. Here derivation we do not require for competitive. m1 m2 by m1 plus m2 into u1 minus u2 whole square. You will get this if you substitute this velocity in this equation and if you calculate. So very important formula. This mass we will say reduced mass of mu. This velocity they will write relative velocity u1 to whole square. So in these cases, see, all the objects are moving towards right. Let us assume this object is moving towards left. Then u2 we should take minus u2 because it is coming in opposite direction. At that time here you will get plus. At that time here you will get minus because u2 can be taken as minus u2. Here plus only will be coming m1 plus m2. So in previous elastic collision also it will be same. We derived common means final velocity formulas. Whenever both are moving towards each other, u2 should be negative, or u1 also you can take negative depending on the objects. So both are moving in same direction means both are positive. So approaching each other means you have to take one is positive, another one is going to be negative. So this is loss of kinetic energy formula and common velocity formula during inelastic collision. Next we will see elastic two-dimensional collision. Two-dimensional elastic collision. So just how they are going to ask the questions and how we have to apply the equation we will see. So again, two objects m1 with velocity u1, m2 with velocity u2. So both are going to be moving after collision. So m1 is going to be moving with velocity v1, m2 is going to be moving with velocity v2. So by making an angle theta 1 with horizontal, theta 2 with horizontal. m1 is making theta 1 means velocity v1 is making theta 1, velocity v2 is making theta 2. So for this, whenever two dimensional we are getting, so we cannot discuss properly. Therefore, this one we will divide into two one dimensional. One is along x axis, one is along y axis. During projectile motion we discussed. Therefore, resolve this v1 into two components. So this is horizontal component v1 cos theta 1, which is basing theta. So which is not basing, that is v1 sin theta 1. So v1 cos theta 1, v1 sin theta 1. Same like this, v2 cos theta 2, so v2 sin theta. So this is two-dimensional elastic collision. Both momentum and kinetic energy conserved according to law of conservation of momentum. So, but this law of conservation of momentum, first we have to discuss along x-axis. So along x-axis, both the objects are moving along x-axis. Therefore, m1 u1 plus m2 u2 is equal to, so m1. So what is the velocity along x-axis here? v1 cos theta 1. What is the velocity along x-axis of second object? m2 v2 cos theta 2. So this formula according to law of conservation of momentum along x-axis. Now we will see along y-axis. Whenever along y-axis, before collision both the objects are moving along x-axis. There is no momentum along y-axis. Therefore, 0 is equal to this one m1 v1 sin theta 1 upwards. But here it is going to be downwards. Therefore, minus m2 v2 sin theta 2. So call it as equation number 1, call it as equation number 2. And according to law of conservation of kinetic energy, so half m1 u1 square plus of m2 u2 square equal to of m1 v1 square plus of m2 v2 square. So these equations if you apply, you are going to get any question. But one separate case will be there in this, very important. If m1 equal to m2, masses are equal, second object at rest. If it is one dimensional, what we said, they will exchange their velocities. Now what is going to happen in this case means, if you do m1 equal to m2 equal to in all these equations, so in all these equations if you wrote and if you solve this, the solution we do not require. So you will get one thing, theta 1 plus theta 2 should be 90 degrees. Means angle between these two objects will move perpendicular to each other after collision if their masses are equal. So how they will ask question on this means, so one object is moving after collision 30 degrees. So if same mass is going to be moving, how much angle it is going with horizontal, they will ask. If masses are equal, then if it is two-dimensional collision, sum of two angles is going to be 90 degrees. So if it is 30 degrees, it should be 60 degrees. When this case will be coming means this is the condition. So they will be giving in question without knowing to you. So therefore you have to identify in the exam, you came to know that, isn't it? So masses are equal, second object at rest. So both the objects will move perpendicular to each other. So this is nothing but two-dimensional elastic collision. So either they will give what is angle between two equal masses, otherwise one of the object is moving some angle, what is the remaining angle they will ask. So this is two-dimensional collision.